Well, hello folks, and welcome to episode, I think, 192 of Retro Power and Cut. Hopefully that's right, or Jamie will have to edit in somebody who's not me saying another episode. But anyway, I think it's 192. And we're going to start, unusually, not with the Jensen, because nothing really has happened on the Jensen this week. As a little explanation for that, today is Tuesday, and we need to shoot our week's footage on Tuesday because Jamie is travelling to Ireland. We've allowed him a couple of days off. So he's travelling to Ireland to see some friends, and consequently he needs to get the video wrapped up quite early this week. So the progress on this side of the workshop is moderately limited, but there are still enough things to be worth showing you, I think. So we're going to start with the Jaguar XJ coupe project, and we're going to start, actually, because we're already stood here, I'll start with the Sill, and then I'll elaborate a bit on what Tom's working on the rear valance. But starting with the Sill, basically repair progress has moved forward, obviously, because the Sill is now attached to the car. So Matt has finished getting the Sill all the correct shape. He's got the end cap sections modified to the correct shape, both ends. Obviously you saw last week that he'd got the new buttresses made that go between the A-pillar and the inner sill. Got those done. He's got the inner sill repair all done, as you saw last week. Then the sill drain section that goes in the bottom of the quarter panel in here, the top section of the sill that goes in there that forms a drain which comes to this tube, he's rebuilt. He managed to extract that drain section from the old sill because it actually, amazingly on this car, wasn't rotten, which is very surprising because that's one of the first bits to rot on these. Amazingly, it was in pretty good condition. So he's extracted that, repaired all the edges where the welds were drilled off and sort of a bit frilly. So he's repaired all of the edges on it, remade those, and then welded that into the top of this new sill and repaired the drain tube and extended that so it comes out through the sill, hence what this is here. That's going to be cut off obviously later on, but he's got that through the sill, got that all in place, got everything prepared, everything cleaned up ready, and then got the sill fitted, tacked in place, not fully welded yet, but all tacked in place, fully welded along the bottom. We couldn't actually get good enough access with the spot welder along the bottom of here, so this has been plug welded very neatly, all done nicely, but we haven't got the access with the, basically our Techna spot welder with our little, the manual clamp on it, will get in there with a flat pad electrode, it will get in there, but we're not very convinced by it on anything greater than sort of 20 gauge steel. 2 layers of 20 gauge gives a reasonably acceptable weld. Anything thicker than that, we're not really very convinced by the weld quality. So this has been plug welded to make sure. Our more powerful welder, the Vilander and Sill welder, won't get in. We haven't got any tips that will get into the space on this, so we couldn't use that, hence why that's been plug welded. And so you'll see some plug welds here just while this is being sorted out at the back. And moving on from that, Matt's got onto the rear trailing arm, the radius arm mount panel. He's got that all cut out, cleaned up, various bits of repair work done around that, and then got the radius arm mount panel, and he's had to replace the outer end of this this sort of slanted panel, I don't know what you'd call it, but this sort of step panel underneath this box that ties into the radius arm mount. Got the end of that repaired as well, because you need to remove that to enable the removal of the radius arm mount. And then he's currently just about to start rebuilding the radius arm, it's like a bell shape that the radius arm actually bolts onto. I wander over here and show you what it, there's this gusset here, that's the original radius arm mount with some dubious repairs on it. That's, can't actually remember what that is now. I was about to say it's the tab carrier, but I don't think it is. I think it was just a jacking point actually. Yeah, I can't actually remember what that one is now. There's a gusset on there, and then there's the actual top piece, which I think Matt may... Ah, there it is. The bell-shaped bit, which is what the actual radius arm mounts onto. The bush pushes onto there, and then the bolt retains it. So he's got that off. He'll get the gusset off, clean them up, get them blasted in the cabinet inside so they're all cleaned up, and then get them welded on. He's got the location for them, so he can get them attached back onto the car again then. And that pretty much... wraps up where Matt's got to, making really good progress. At that point, this side's going to be pretty much done. Once the sill's all fully welded and a few bits are cleaned up, this side's pretty much done, and then it's moving on and it's pretty much ditto the other side. The only bit where we're crossing fingers is whether that drain section in the top of the sill, the other side, the water drain for the rear opening quarter window, whether that will be in good enough condition to reuse that side as well. We'll have to see. We won't know until we get it apart, get the sill cut off. We can actually have a look in there and see. If it won't go again, we'll have to make it. It's not available. Making it will involve a bit of a press tool and a bit of shaping work. So it'll be fun to make, to be fair, but equally it'll be a lot less expensive for the customer if we don't have to make it. So it's one of those, always a balance to these things. It's quite nice to make tricky bits like that, but obviously it involves time and expense. Then I'm going to run round to this side just because it's easier to get through this side and gesticulate at the rear of the car where Tom is working. I'll lift this off for a minute to explain what's going on in here. I can't remember if we had this, no, we didn't have this fully opened up last week, so now you can see what's going on in here. Tom's completely removed the bumper mount this side and just cut the back off the bumper mount this side so that we've still got a reference point of where it was all fixed. We're going to revise the bumper mounts. Viewers may be able to enlighten me on this. I don't really know why Jaguar made the bumper mounts out of this large diameter tube. I know why they'll have tied them in as structurally as they have, but the large tube's a bit of a mystery because there's just a very thin bolt passing through the middle of that, a 3/8 inch I think, bolt passing through the middle of it that actually holds the bumper on. I suspect they were a Federal bumpers thing and they had an impact absorber inside them for Federal markets. Is the only thing I can think of. I know sort of newer vehicles tended to have those impact absorbers in there, so I do wonder whether that's what was in there originally, because I can't really see another reason for that. But what we're going to do is change that and put a much smaller tube in there that's less obtrusive in the rear valance. And I'll do a little rewind at this point because I perhaps haven't gone into any detail on why we're doing some of what we're doing here, other than, oh, it's a rot trap, which it is. If you long-term viewers and those familiar with our previous work may have seen the XJ coupe with the LS3 Chevy V8 in it that we built some time ago. I know we had that at the Classic Car Show at the NEC in 2016. I think it would have been finished and handed over to the customer in mid-2017, I would say. But certainly we had it at the Classic Show, autumn 2016, as largely finished, but without an interior in it. And on that car, we modified the rear valance. Again, really big rot trap, and the customer wanted a different, wanted a redesign of the valance and wanted separate quarter bumpers. And actually, interestingly, we had an inquiry from somebody the other day asking us about quarter bumpers and whether we could make them a set, or how we got them, I think was the question. Well, we made the quarter bumpers for that car using sections of other bumper and some bits we made up to make the quarter bumpers for that car. But obviously it leaves this middle ugly bit of panel and the bumper mounts all exposed, and you can't just leave them exposed, they'd look awful. So that all needed removing. So we had to remove the rear valance, at which point we remade it without the big step section in the middle, and we also made it removable and made it a bolt-on panel so that it was removable, so that we could treat inside it, and we actually zinc metal sprayed inside it so that rust wasn't going to be an issue. In fact, there's a video of that car being zinc metal sprayed on YouTube, actually, one of our earlier videos that we put on YouTube of me zinc metal spraying that body shell, which would have been in, yeah, probably early 2016, late 2015, somewhere around there, I would think. That was one of the earlier cars that we actually zinc metal sprayed. But that's why we redesigned the valance on that car, and also the customer wanted a change of exhaust design and the way they came through the valance to look a lot neater. So we redesigned the whole valance, made it bolt-on, and redesigned the back of the car to take this double step out so that it looked much more pleasing when the car was fitted with quarter bumpers that didn't hide this middle bit. Now, stepping forward to this car, this is keeping a full rear bumper, not quarter bumpers. This customer wants a full rear bumper, albeit slimmed into the car a little, with a few bits of redesign, but still a full width rear bumper. So we can keep the step section in the centre on this because it will be hidden by the bumper, which makes life slightly easier for us. And it also means that we can actually bolt the valance. On the previous car, we had to hide the bolt line. On this car, we can have a visible bolted line with some very small little button head bolts, because again, they'll be hidden by the bumper, they won't be visible. So that's what we're going to do. We're actually going to put a stepped panel joint in between the back of the valance and the back of the car here. We're going to put a step joint in here and bolt this with spot welded on nuts inside the valance, so that this step's the correct way for water to drain downwards, which is obviously upwards at the moment because the car's upside down. so that we can have a bolted joint along there, and then this will be trapped in at the sides by the rear corners, bolted down there, and then there'll be 2 rubber bump strips inside here to support that and stop it buzzing on the boot floor sides within there. And then, as you can see, Tom has made up and TIG welded in these closing sections to weld up and delete the original bumper mount holes in this valance panel, and then we will put a much smaller, neater bumper mounting through this, a much smaller tube through this to support the bumper mount, to carry the bumper without having the great big hole and buttress and all the other sort of ugliness that was on here originally, just to make it look neater and cleaner, but still have the strength. I mean, obviously we actually mount the car to our rotisserie using those 2 points and 2 points in the boot, so it needs to be pretty robust. So we, just from a producing the car point of view, we need two robust mountings in there. And also from a bumper mount point of view, we still need to be able to mount the bumper to them. It's just that I don't see any benefit to using these great big, these sort of tubes, these mountings of this sort of size. There's no reason whatsoever to need to use those, so we're going to get rid of those. And then also we're going to make the front edge of this bolted along the back of the boot floor. This will be bolted and flanged down here, and then there'll be bolts accessed from inside the boot that retain this panel along the back edge of the boot floor. That'll be retained by some bolts accessed from inside the boot. So it'll be bolted along here, bolted from the inside of the car along there, and then bolted through the outer quarter cappings down there. That's the valance secured, but it means that during the zinc blast, zinc metal spray, and all the paint, prep and paint operations, this can be removed, everything's accessible, the inside of that can be coated, no rust in there, none of this horrible rot trap that condemned a lot of these cars to history due to the corrosion of the rear end of them. So that's the plan on the back of there. I think that pretty much wraps up where we're at on XJC. Say next week, Matt will be moving on to the other side, which was the near side of the car, in getting all of the same repair work done on that side as he's been doing on this side. But we're getting pretty well through this now. It's marching on at a good rate. We're moving on nicely. Moving on from that, I think we'll have a quick look at the E-type. I reckon if you go that way, Jamie, and I'll go this way, and we can point at a door aperture, because Bobby has continued work on this. I'm going to talk about it this week briefly, because Bobby's actually split his work between this car and a bit of work on the Allegro as well. So there's a bit less to go into than there was previously. So I'll do a little explanation then. I'll perhaps get Bobby to do another follow-up next week on where he's at once he's spent some more time on this, because at the moment his time's been pretty limited this week on it. I think we had a question about, or somebody mentioned about using soft closed door latches. I think we picked up, I don't know if we picked up on that as a question before, but exactly right, and I think I said yes we are, and the beginnings of that are now in evidence here. Bobby's just working on the mock-up parts and brackets to be able to fit these Tesla door latches to the B-pillars. Now these would normally fit into the door, and the striker would normally be on the pillar in a Tesla. On this we're reversing that. We're fitting the latches into the B-pillar because we haven't got room in the door, and we're fitting the strikers to the door where we have got room for a striker. So we're reversing that, and then we're going to redesign, or Bobby's going to redesign the door seals to work around this, because obviously it's going to obstruct the existing door seal arrangement. So there's going to be a redesign of the door sealing to cope with this. These soft close catches are being put into the B pillar, and again we've trialled all this. They will pull the door in nicely. They'll latch and pull the door closed, so the door will shut on its little servo, or its little stepper motor. It's actually, no, it's not. It's just a DC motor, isn't it? The door will be closed on its sort of basic DC motor. Once it hits the catch in the striker, then the striker will grab it and pull it shut and latch it. That's the way all of this is going to operate. But Bobby's just at the early stages now. He knew from measuring up and checking before, he'd got clearance for everything to fit. It's right on the ragged edge of feasibility, but it does fit. So he's just in the early stages of fabricating a trial box to mount the catch into and actually get it into the structure of the B pillar, and then we'll get all that finalised and that'll be ready to go. Then at the other side of things, if I whiz around here, He's also done a little bit of work at the hinge end of things, which you saw last week, but he's continued and got it to the stage where he's now got a pin switch mounted in it. It's actually an old Jaguar sort of XK type pin switch. Jaguar used them for many years, but it's a Jaguar pin switch that he's managed to incorporate into the hinge mechanism, or the prototype hinge mechanism. So the prototype hinge mechanism is pretty much there or thereabouts now. Now, obviously, it's a long way from being the actual final thing, but in terms of its form and its function, it's all there now. You know, it bolts in, it's fitted into all the things, it does all the things it needs to do. It's now just got to be made a bit stronger and sort of a production item rather than a prototype. So yeah, good progress being made. And we're well along the way, or Bobby's well along the way, should I say, of getting the door mechanisms sort of all up and running, which is one of the bigger engineering challenges of building this car. There's quite a lot of work involved, but it's progressing well. So I think that's pretty much where we're at on E-Type. Moving on from that, Bobby's also worked this week on the washer bottle mountings for the Allegros, one of which is there and one of which is behind camera over there in varying stages of body prep. We'll come to that. One of the items that was 90% there but not quite done was the windscreen washer reservoir mountings. We had been waiting for a long time. We get those from a company called Doga Automotive in Spain, and they've been on back order for quite a while. We finally received those. We'd used a 3D print using the data we could get about those reservoirs, but it wasn't completely accurate, particularly in terms of the mountings. So Bobby had left the design deliberately loose at that point and not put the mounting holes in, not put the mounting points in for them. So he's now we've just received those reservoirs, so Bobby's now gone ahead and finished the brackets, finished putting the mounting holes in, finished making sure everything works, and trialled them on the cars just to check that everything works, so that we can then get those brackets coated, because I believe that Adam is just currently gathering together another shipment of parts to go off to East Midlands Coatings for Xylan coating, our PTFE, the PTFE coating that we put on parts like that where we don't necessarily want to powder coat them. But again, I'll probably leave that to the guys next door to talk about. But yeah, so Bobby's basically just finalised those brackets and got them to the stage where they're ready to go on the car now, which wasn't possible before. Further moving on from that, I'm going to gesticulate over to a welding bench where Tom isn't. But Tom has also been doing some work on something that Cal's going to mention in a little bit, which is some exhaust system parts. And he's been TIG welding some stainless steel exhaust system parts, because we've been doing some little modifications. So he's been getting through that work, which is the sort of the nice cleaner end of the fabrication work going on in the workshop, where we're doing a back purged stainless steel TIG welding work. We're using, for those interested, going on a slight elaboration on that, the exhaust tubing that we're generally using will largely be 304L stainless. L in the stainless steel stands for low carbon. Most of the stainless steel 304 or 316 stainless designed for wrought type work, i.e. where it's got to be worked and not left in its original shape, would be L type low carbon stainless steel. And most of the exhaust system stuff that we deal with would be a 304 stainless, occasionally 316, but largely 304 stainless. And when welding that, it's quite important that you try and avoid air getting to the back of the welds. Stainless steel has a habit of crystallising on the back of the welds, and it forms like stuff that looks like coal on the back of the welds. If you let air get to it, it oxidises, crystallises on the back. Tiny bit, not going to be, on a NASA mission, absolutely critical you don't have any of that. In the real world, if you get a tiny little bit on the back of the odd weld that isn't particularly highly stressed, it's not going to cause too much bother. However, it's best to try and prevent it, and certainly on exhaust systems, the vibration can cause cracking, and it tends to propagate from any crystallised areas on the back of the welds. And it's also flipping difficult to weld. If you've got dirt on the back of the welds, it makes welding the front side of the weld much harder as well. And it's very hard to do any autogenous welds, i.e. welds that don't have filler rod in. It's very hard to do them if you don't back purge the weld. And in some cases, some of these welds won't have needed filler rod, but you would need to put filler rod in simply to kind of get rid of the oxidization if you don't back purge. So all of the welds that are being done there are being back purged. So if you see bits of the footage where we've got a little pipe going to some foil over the end of the pipe, that's our purge setup, where we've got a second flow meter on the bottle. We've got a pipe from the second flow meter going to a little quarter turn valve, and then going to some just windscreen washer tubing. We just use cheap windscreen washer tubing for the last part, because at some point at the end always gets melted off it while you're welding. I've done it countless times, so I'm not going to blame anybody else. But and I'm sure I could get some PTFE tubing that would last longer, and I'm sure there's 1,000,001 ways to do it. What I tend to do is just use some cheap and nasty PVC screen wash tubing, and if the end gets melted off, you just snip it off and reuse it, and cut it back until it's too short, and then get a new length. Easiest way of doing it, really. But then we just put HVAC tape, the foil HVAC tape over both ends of the tube, which prevents gas, keeps the air out. Put a hole in at one end, poke the purge tube in there. At the other end, put a little pepper pot of holes in. Bear in mind when you're doing all this that argon is heavier than air, so you kind of want it to start at the top and fall down through the tube and drop out at the bottom. Always imagine it being like water, because that's how it'll fill a tube. And so use that to purge the tube, push all the air out, or drop all the air, push all the air out the bottom of the tube, or float the air out the top of the tube, depending on where you put your holes. But basically clear the air out of the tube so that you don't get any crystallization on the back of your welds. So that's what Tom's doing in the bits of footage that Jamie's got there. Is he's back purging those pieces of exhaust tubing, and then TIG welding up all of the various tacked joints that have been made to end up with a final piece of exhaust system, which again I'll let Cal reveal more about exactly what's going on there. But that's what Tom's been working on. At that point, I think there's various peripheral jobs going on, but I think we'll elaborate more on those when we've got a bit more to show. And talking of peripheral jobs, I'm going to hand over to Mark. It'll be brief because, for reasons Mark will explain, but I'll hand over to Mark now.
All right, viewers, got a new employee started this week. Steve's still AWOL, probably passed out in a tent somewhere. We've got this new lad. He looks very like Nathaniel a bit, or Nat, a little bit, but it's not. He's very good.
Just needs a bit of training yet.
Oh, he sounds like Nat as well, doesn't he? He sounds like Nat.
Can't stand.
Right, we're going to have an autofocus on this now. We've got sandpaper, dust.
More dust. Dust creation.
We're not in Colombia. But yeah. So this is Nat doing the mould for the splitter. You're going to lay some glass in a different way, aren't you, Nat? No, it's not Nat. It's not Nat.
New boy.
New boy. New boy. It's just new boy. So yeah. We'll probably get onto it more this week. You're going to get onto this week.
Hopefully. Hopefully, we will, later this week I think. We've got sand it, get it to 500, and then wax, 5 coats of wax, and puff it back, then PVA release, and then lay it up and see if it goes wrong.
Laters.
So thank you, Mark, and as if by magic, here we are next to some fiberglass work. So mentioned last week we were going to be doing a little bit of fiberglass work. I've been doing a little bit of self-training, video training, Google training, whatever you want to call it. But anyway, here is the result of that mould tool that you saw being machined and finished last week. I think we machined that on end of Wednesday last week, possibly. I think, or it came off the machine Thursday. I can't remember. Maybe Thursday. We took that off the router last week. Then that has been sanded. The MDF, the finished machine surface of the MDF, was sanded to 180 grit. I think that was sanded to 180. In fact, no, I think I took that to 320. Sorry, no, I think I sanded that to 320 on the MDF. and then kind of cleaned it all up as best I can, because it tends to have quite a fluffy sort of surface in places, and it tends to absorb any coating you put on it tends to absorb and clump and just not go on very nicely. So I sanded it as fine as I could sort of really manage, given that it was fluffy MDF. So took that to 320, and then 2 coats or 2 hits of sprayed polyester. Tinted the first one just to give a bit of a clue as to when, how far down the sanding was going subsequently. So two fairly big, heavy hits of polyester on that. One tinted greyish, had some black polyester tinter, so just put some of that in. Would only tint white polyester as far as grey, but that'll do. Tinted that grey, second coat just white. Then sanded that right down to 500 grit at that. So I went on with probably 180, and then 320, and then 500. That's a 500 foam backed paper. Well, that's some 320, but basically the same as that soft hand stuff, foam backed sanding pad. So that was all sanded to 500, a reasonable sort of felt smooth, reasonable finish, not too many scratches and mess on it. The body shop guys would have said it was rubbish, but it was sort of reasonably sanded in my book. And then loads of wax. Basically, it has then 5 coats, 5 wax on and offs of that, basically, of Stoner Miracle Gloss. So yeah, 5 wax on and offs with that. And then PVA release coat, which is that, which is just from East Coast Fibreglass Supplies. Pretty most of the stuff that we're using comes from East Coast Fibreglass. It tends to be either East Coast Fibreglass Supplies or Easy Composites. If I was doing anything carbon related and probably anything epoxy related, I would probably tend towards Easy Composites. They're probably the better source for all that sort of stuff as a one-shop place to go for that sort of stuff. When it comes to the fiberglass side of it, the GRP side, I'd probably tend more towards East Coast. They've got a bigger range of stuff than Easy Composites have when it comes to fiberglass type work, which is what we're doing here. We're not trying to run before we can walk. And then, yeah, that was yesterday. You got the PVA on, that was Monday. Got the PVA on at the end of play yesterday, and then today laid up sort of a sequence with glass fibre tissue, obviously gel coat first, a grey gel coat first, then once that let that cure off to go tacky, then fiberglass tissue, which helps stop the mat jabbing its way through the gel coats, helps stop it jabbing through and kind of being evident and printing through onto the outside, just gives you a barrier. So put some fiberglass tissue in first, and then 110 gram mat, and then 220 gram mat, I think it is. I lose track of what all the grams are. Then 300 gram mat, most of the layup then in 300 gram, and then can't remember if it was 1 or 2 plies, I've lost track now, then 2 plies of 450 gram. And then that's where it's at now. And really the next phase is getting it out of the mould. And no, unlike what Steve's just said a moment ago, I'm not going to try and do it live on camera now, because I'm sure it won't be a 2-moment job. But yeah, it's all in there. We'll find out whether it's worked or not in a bit. But yeah, that's hopefully, fingers crossed, touch wood, the first Allegro front splitter ready. We'll find out. Hopefully it's worked. And on that note, I think it's probably time to hand over to Cal and see what's going on next door. So, see you in a week's time.
Well, because Jamie is inconsiderately going on a jolly to the Emerald Isle, I think we're really one day since the last video, so it's only Tuesday today. So it's thin on the ground in terms of stuff, but I'm sure I can pad it out. I've got some questions I'm going to cover. I know it's literally just about lunchtime, so this is what was referring to the dusty crew will be everybody from the metal and body shop coming through. So we'll meander around them for a bit, that'll absorb a bit of time. Starting with a nice brownstone coffee. We shall see what we've been up to. Okay, that'll do. Right, follow me this way. So, Project Churchill, let's start with that. Mark is literally just starting some Dynamat installation on that. So, and what was the other thing? Oh God, I've already lost my train of thought. What was Luke up to? Somebody else has been doing something on this. Luke. Ah, that was it. Yes, I've remembered. Rear lights. So the bezels around the rear lights. We started modelling these previously, but then decided we'd better wait until all of the bodywork, paintwork part was finished. So he's just done a rescan of the back end so he can model the rear lamp bezels, which are going to be machined. I would imagine we're going to machine them in brass and then copper plate them, because all of the exterior bright work on this is going to be copper plated, like polished copper as the final finish. So he's modelled those. They're basically ready for me to do some final checks. As I just said, Mark's on with Dynamat installation on this. Just always use Dynamat on the cars. Just get some of the resonance down, noise levels down, a little bit of thermal insulation in there as well, so keeps some of the heat from the exhaust, etc. out, and insulates so your air conditioning works better. So yeah, that's where we're at with that. You can also see down here, we've just been trialling the mock-up rad. When Stu did all the metalwork, he's fabricated a mock-up radiator, but the one thing we just wanted to check was the neck height, because he never fabricated a dummy neck on it. So I just wanted to get that in, check the bonnet clearance, and fabricate some sort of dummy neck so we know the height that we can take up with that. So when I send that to Concept Racing to make the final radiator, they've got all the dimensions they need. So that's that. Let's have a little wander this way, past these two fuel tanks. So I was talking last week about all of the preparation of parts for the Integra Allegros. One of those things is these fuel tanks, so they're going to be blasted and repainted, but they're the original Integra fuel tanks. And interesting, there's a revision, and it must be between the 2 years. So one of them has got a rollover valve vent plate in the top of it, in sort of a round bolted flange. There's 3 bolted flanges on it, one for the fuel pump, one for the sender, and one for the vent. Whereas the other one doesn't have that round flanged rollover valve in it. It literally just has a small pipe on the corner of the tank, and that pipe internally in the tank goes right up to the top, so it vents out through that pipe. So there must have been a revision in one of the years, but not a biggie. A lot of the stuff's available from Honda, and that's one of the great things about Honda actually, and some other car manufacturers, is really good parts support. And in the case of Honda, they've actually got an online catalogue, so you can go online, look at all the makes and models, bring up the parts diagrams, and actually buy via their own website, which is pretty cool. So that's that. Oh, sorry, I'm giving Jamie the runaround a little bit here. Just cleaning up the glass, actually. This is Allegro, so we're just inspecting the condition of all the glass, seeing if there's any minor scratches, etc. Generally very good. Both rear windows are great. Both windscreens have got damage, but that's not a problem because we can get new windscreens for them. Side glass, generally good. A few little light scratches, which I'll probably get professionally polished out on those. Obviously, Austin Allegro glass, brand new, not being a very readily available thing. Project 1, Super Stu is on with the exhaust. So we're doing some revisions just to try and get the exhaust noise down slightly, the resonance in the body shell that was being generated from the exhaust, get that down a bit. So the further forward section, which is the section that sits under the floor, done a little revision to the gearbox crossmember to allow us to kick the exhaust slightly more to the side, so we could then put in a very slim box to knock some noise down there. And I think he's just working on the back box at the minute, which was just a simple round straight through box. What we're doing in there is we're just switching it to an oval box, and we're going to do a crossover within the box as well. So the input as it comes over the rear subframe will be on this side of the box, output that side, and we're actually switching from the very neat sort of discrete downswept tailpipe, which did look good, to a rear facing tailpipe, because I think there's a little bit of exhaust pulsing kind of coming up through the boot floor from that down facing tailpipe. So hopefully that combination of changes will give us enough. I don't want to make it whisper quiet. I mean, nobody wants a BDG powered Escort that's whisper quiet, but we just want to kill some of the resonance that's coming through into the body shell. Anti-roll bar we've swapped out for a 19mm bar. It was a 16, now gone to a 19. See how we get on with that. Just a revision on the clamps as well. The anti-roll bar setup's a Rick's Motorsport setup on these. And perhaps, I don't know if it's oddly or not, but the 16 bar has smaller clamps. It has Ford KA clamps, which have a slightly different bolt spacing, which is a bit of an oddity because it means you would need to change the bolts or the holes in the brackets that they attach into to switch between different bar sizes. However, we've identified a different anti-roll bar clamp that can still bolt into the bolt spacing that we'd done for the 16mm bar and accommodate the 19. And there's a 22 as well, which we could go up to. But we're going to try it on the 19, see how we get on with that. So that's that. Next thing, twofold actually in terms of where this work is going on, but the Saab project, very exciting project. We're all looking forward to getting onto it. The Audi arrived last week, which you saw. We're just planning the strip down of that. And in the meantime, the guys have done a scan of both the Audi and the Saab, so we could basically investigate the next stage of feasibility. So we're looking at, it's a bit similar to the Integra and Allegro projects, where we've done basically a floor pan transplant body shell. And looking into the feasibility, there's kind of multiple stages. So it literally starts with the thought process of what would be suitable, and then move on to rough dimensions. And initially we just scale a side view of it's like a blueprint side view that we found on the internet of the two cars, scale it and overlay it and say, well, there is a reasonable chance that the things are going to be in the right place. And when I say things in the right place, what I mean is if you line up the front axle line, whether the engine would fit into the engine bay, whether the scuttle or the back of the engine bay is somewhere in line with the base of the windscreen, so you don't end up with half the engine bay under the windscreen. The driving positions are the controls roughly in the right place, so pedals, gear shift, steering wheel, and the seat ends up in a sensible place, similar to the original car, so you're not ending up sitting in the back seat area. And the wheelbase, the width is within the realms of where you want to go. Obviously, we want to visually widen this out, the Saab, so having a wider width of wheelbase is good. And then track width, should I say, get my terms correct. And then the wheelbase is longer on the Audi. We knew this, but we know we can also shorten the floor pan slightly, which we did on the Integras as well, the Allegros. So we went from that to then, we're pretty convinced from that, let's move to the step 2, which is getting the two cars and then doing some initial scan work, but not stripping them down, so we can still sell them if it doesn't look like it's going to work. So that was phase 2, which is what we've done this week. So we've got a scan of the Audi which shows seats, pedal position, gear shifter, steering wheel, engine bay, and then we've overlaid that with the Saab scan to see where everything falls, and it's all looking very promising. So now we're going to move on to step 3, where we're going to strip the cars completely. So we've been organising shelf space ready for all of that stripped down. We'll crack on with that, and then what we'll do is, once we've got the bare body shells, we'll scan the two body shells in detail at that point, and then we'll be able to overlay the two body shells in CAD and literally work out exactly where we're going to make the cuts, which sections we need to make, which bits of each shell we're going to use. So watch this space on that one. But that's what basically Luke and George have collectively been working on. And then I think George was also, in fact I forgot this when we walked past Churchill over here, George is on with the front spring pan. So actually I'll tell you what, I was going to walk back towards the car, but subframe, cast your minds back. We designed this front subframe completely from scratch, so to tackle various problems with the Mark II front geometry, but it's running X300 XJ lower arms. These are obviously just some cut and shut mock-up upper arms, but these are currently being machined for us, and I think it's, what would it be, mine's gone blank. A very strong grade of steel, but I'll report back on that next week. And then we've got rack and pinion steering on it. The one thing we haven't yet completely finalised was the lower spring pan, which would bolt into the lower wishbone, normally holds the actual coil spring in an X300. That's going to be the lower mount for our coilovers, which are going to mount into these clevises at the top. So George has just been drawing up those lower spring pan parts so we can get them made, all basically leading up to being able to get Churchill rolling. So that's where we're at with that. And on that note, I'm going to grab my phone and do a couple of questions. So, Don Finch 862, have you looked at Haltech ECUs? Lots of combinations of ECU and PDM. Love your show, cheers from Perth. Well, thank you for that. And a few people mentioned Haltech, and actually no, we haven't used them yet. There's no particular conscious reason for that. One thing that piqued my interest about them a while ago is the fact that they do a combined PDM and ECU. However, when I looked into it, we decided not to use it because it doesn't really have enough inputs and outputs on it overall. That's one of the things we often struggle with PDMs, is because we're using analog switchgear rather than the CAN bus keypads. In a motorsport application, you would generally have the PDM connected to all of the electrical devices on the car, of which there don't tend to be that many in a racing car. And then you'd have a little CAN bus keypad, which just has CAN high, low, and a power connection. And that basically does all the switching. Whereas because on the cars we're running them in, we're tending to use a lot of the original switchgear, column controls, headlight switches, electric window switches, all of these different things. We need a lot of inputs. And even the things like Motec 30-channel PDMs, they only have 16 inputs. And we do tend to find that limiting, and that often is the reason for us running twin PDMs. So the Morris, Project Utah, the Allegros, they're all running two 16-channel ECU master PDMs, which gives us 32 inputs, 32 outputs, which is generally enough. So yes, that in terms of PDMs, that tends to be why we've not gone with the Haltech stuff, and why we've not gone with various manufacturers' PDMs. Now you can add more. If your engine ECU has got spare inputs on it, you can input some switchgear to the engine ECU and then transfer that information via CAN to the PDM, which is a nice way of expanding. ECU Master have also got some nice little CAN expanders, so you can add extra analog channels and then basically tell the PDM what those channels are doing via CAN. So there are ways around it, but yeah. Waffling on as I do. Basically, we haven't tried Haltech, no particular reason, and we probably will do at some point. Interesting, actually, if people wanted to give any comments. If anybody has tried lots of different ECUs, feel free to add your pros and cons as comments, because we've certainly got various pros and cons, and it'd be interesting to hear other people's. Max Talk 2277. This is regarding the E-type close. Have you got soft close catches for those auto doors? It's really difficult to get slowly closing doors to shut nicely, as they need to compress the door seals. Here a soft close catch really wins, because it can provide a very controlled, very high force final 10 millimeters or so of movement to ensure the door is actually shut and latched every time, no matter what happens. Yeah, we are doing, yes. The whole mechanism setup is basically Tesla. And we are using the Tesla soft close latches as well, and that also tells the system when there's switches in there that tell the system when the door is closed or not. Yes, that is the intention, and you will see this over the coming weeks, but we're switching the striker to being on the door and the latch to being on the pillar, because there's not enough room in the door for the Tesla sort of soft close latch mechanism. So the latch is actually going to be on the pillar itself, and then we're going to have a mechanical release system, but that will be basically a pull lever somewhere in the cabin of the car next to the seat probably, so you can mechanically release the door as well if you want to. And Bobby was very keen to put through its paces how easy it was to just overcome the motor, which is very easy. So there are fail safes in there in that you can mechanically open the door from outside or inside and just pull it and shut it. And also, this wasn't a specific question, but we will be having a proximity sensor on the door so it won't open into something. And this person also said about having a position sensor so that you can do closed loop control. So the system always knows where the door is. Well, that's already integrated into the motor setup. So the motor has feedback on what position it's in. So that's all good. Right, what was this one here? Tony Wall 8393, really interesting comments from Cal at the end about electric cars and Citroens. I love the Citroen DS. I'd be really interested to know where you might go with a DS with conventional petrol power and what you might do with the suspension. It's funny you should ask that, because I've been having this conversation with a client of ours about building a Citroen DS and which way we'd go. And it's an interesting one, because so many of the cars we talk about amongst ourselves here, potential projects, there's an obvious go-to route, and somehow there didn't seem that with the DS. It's like, what engine would you put in a Citroen DS? Seems like, I'm looking at Jamie behind the camera. What would you do? I mean, they did that. PD130. PD130, yeah, terrible. Oh, I mean, yeah, it's a tricky one. I mean, my obvious sort of Peugeot Citroen group go-to in terms of a petrol engine would of course be an MI16 engine, but then it's putting an MI16 into a DS somehow doesn't seem like the right match. It seems more of a sort of effortless wafter than a 4-cylinder aggressive throttle-bodied barking machine. So I really don't know. It's a good question. That's a great one for people to comment. If you were building a Citroen DS but keeping it internal combustion power, what would you do? Because I'm at a loose end on that one, really. What else have we got here? This is a good one. Coupe. My question for Cal: where do you get those cool work shorts? I think I've seen you wearing long versions as well. Now he said long pant versions, so I'm going to make perhaps a generalised judgment here. This might be somebody from the US. So these are actually DeWalt ones. I mean, certainly in this country, this is a fairly standard workwear thing for tradesmen, man of the trade, to have lots of pockets and that sort of stuff, and they are very good. Previously the trousers are generally Snickers, and I've got on very well with the Snickers work trousers. So yeah, DeWalt or Snickers. I don't know how readily available those brands are in other countries, but certainly here they're great. We get them from just your usual trade supply places, Screwfix, that Tool Station, that sort of company. Some1239, I'm waiting for the Symmetry project. Well, yes, we all are. It is ongoing. It's just at the moment there's no point us progressing with any of it because we're having the chassis built, and we need to have the chassis here and in front of us to then do a scan of that chassis to then carry on with the body modelling work, because we've got the basic outer sort of shape of the car, but all of the detail work relies on having a chassis. So that's why there's nothing going on with that at the minute. It's progress, but it's not under this roof. I've highlighted loads of these actually. Phil Tucker 1224. I feel like I might have answered a question from you before. Talking about ECUs, I would like to know why, say, getting 300 horsepower from a mapped and dynoed 2-litre performance engine nowadays seems normal, when using a similar engine block with carbs 50 years ago would be difficult. That's an interesting one. I would say 50 years ago it probably wasn't that easy, but certainly in the engines we're talking about are largely engines from the 80s and 90s, I would say, and maybe a little bit from the 70s, when motorsport and manufacturer development of engines that could be used in motorsport, and therefore a focus on performance, was a huge thing. So the engines you're talking about getting 300 horsepower from a 2-litre, well, these would be things like the Vauxhall Red Top, Ford Duratec, Ford BD potentially, although it's pushing the head design on those a little bit. BMW S14. These are kind of engines from the touring car days. A Ford YB, naturally aspirated, development of that one, something like the Millington Diamond engine. Yes, I would say number one reason is that they were performance design engines where the head design, once you put a bit of extra work into it, the fundamentals of the port design, the valve angles, everything kind of was designed for performance. But the secondary point there is carbs versus injection, and actually it's perfectly possible to get those power levels on carbs. Any of those engines that would make 300 horsepower on injection would make that on carbs as well. The problem would be that although you can get the carbs to get the fueling perfect at an exact particular RPM, so you can get the fueling perfect at the engine's point of peak efficiency in the RPM range and make that power, they wouldn't be right elsewhere, and that's fundamentally the problem with carburetors. Because of the way the air flowing in is what draws the fuel in. Although you can optimise it at a certain RPM, you can't optimise it at all RPM, and that's really what led to the development of fuel injection. Is that the fuel injection, regardless of temperature, air temperature, coolant temperature, barometric pressure, anything, and obviously RPM, you can get the fueling bang on because you can factor in all of those things. Whereas with the carburettor, they were adding more and more things to try and fudge the basic principles, but they were kind of flawed in their overall design. So yes, it's possible to get that power, a combination of reasons. And engines from the 80s and 90s fundamentally were designed very well performance-wise, and it would be possible to get that power on carbs, but injection, you can get that power and have the drivability elsewhere. Do you use drive-by-wire for idle, or do you need additional air bypass? probably regarding the Escorts, this one, we're using drive-by-wire for idle control, and it is fantastic for that because you can fully program, and it's literally like you're just holding your foot on the throttle. So, you know, when you first start the engine, it probably immediately revs to sort of 3,000. You can even program in a nice little blip when you first start it, as you get on a lot of sort of modern performance cars. And yes, it is completely, there is no additional air bleed because it's not necessary to do that, because all you're doing with an air bleed idle control is just bleeding air around the throttle butterfly, and that is literally the same thing as just cracking the throttle open a little bit. So yes, we do drive-by-wire, and it's actually one of the reasons we are erring towards more drive-by-wire stuff now, is just because it is easier to do the idle control that way. It's a cleaner solution because you're not adding something else into the mix. That almost ties back to the sort of carburetor conversation where carbs are adding more and more things on to try and solve problems, and actually idle control with air bypass is adding something to solve a problem you can do with just opening the throttle. And then the final one I'm going to leave you on, Reggie Dixon 2 Electric Classic Car Channel has done 2 superb electric Testarossas that are no longer 10 mpg dinosaurs. Now, I did a little bit of a snappy response to that and said, and no longer have every bit of enjoyment they ever had, to which there was a bit of a response. So, sorry, but 10 mpg kills any enjoyment I would have had. Well, I must admit, I mean, we probably do a whole separate discussion on this electrified classic cars thing, but I disagree. I mean, for me, a Testarossa, like 90% of the enjoyment of that car was that amazing V12 engine. Yes, it looks good, but in reality, they're thrown together. They're pretty badly built. There's all sorts of knocks and rattles, which you'll notice 10 times more when there isn't an amazing sounding V12 behind your head. I just don't really understand it. And the argument about MPG, if you're talking from a cost point of view, is completely flawed, because you'd have to do some serious mileage in that car to offset the cost of the electric conversion on your fuel saving, and I very much doubt those cars are going to do huge amounts of miles. Now, yes, there's an environmental side to it, and I'm not going to get into the ins and outs of that, but obviously there's an environmental impact of doing the electric conversion as well. But yes, on the fundamentals for me, yes, I'm not against electric conversions, as I said before, when the car is right, but that for me is the perfect example of when the car is not right. You know, you literally, yeah, by all means, upgrade, you know, parts of it, maybe modernise the fuel injection on it, but putting an electric motor in a Testarossa is like putting a diesel engine in the Flying Scotsman. It just makes no sense. Anyway, on that one, we're going to end this episode, and we'll speak to you next week.